In this lesson, we'll be looking at exponential equations leading to quadratic equation. And so, if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we start the meaning of exponential equation, and there's an equation involving powers of numbers. So example, we can talk of 3 exponents x plus 1, which is equal to 81, or 2 exponents y, which is equal to 2 exponent 2. An equation of this form can be termed as an exponential equation. So we have exponential equations leading to 1, linear equations, 2, quadratic equation, and 3, simultaneous equation. But this video is going to focus on exponential equation leading to quadratic equation. And so let's set the ball rolling. So exponential equations leading to quadratic equation. We are saying that if we have a exponent 2x, now with this a exponent 2x, we are saying that we can write it as a exponent x all exponent 2. So if you multiply the exponent x and 2, we are going to get back 2x. In the same way, we can rewrite this one as a exponent 2 all exponent x. So whatever being the case, we are trying to rewrite the exponent in such a way that we are going to have one in the bracket and one outside. So that's the idea. Now that's the first one. And the second one, remember from the laws of indices, we said that if you have a exponent m times a exponent n, we said that provided the base are the same and then they are multiplying, we write one of the bases and we add the exponent. So that's how it is. Now the vice versa is what we'll be looking at. In case you have been given a exponent m plus n. Now this is coming from the fact that the bases were originally multiplying and so they added the exponent. So if you have something like this, it means that the bases are multiplying, and then when we come here, we can see that the exponents are being added. So that's the main ideology here. So in what we'll be doing, we'll be giving a exponent m plus n, and then we will be the one to simplify it as a exponent m times a exponent n. So if that's the case, then remember also from the laws of indices, we said that if we have a exponent m divided by a exponent n, we say provided the base are the same and they are dividing, we can write them as a exponent m minus n. And so the vice versa, when I'm being given a exponent m minus n, it means that the bases are originally dividing, and so they combine or rewrite the exponent as that. So which means that we have a exponent m divided by a exponent n. And so this is the basis to the exponential equations leading to quadratic equation. If we understand it, our solution is going to be very easy and simple. And so let's take our first example and see how we can apply all these things. So in our first example, we are saying that find the value of x if 3 exponent 2x minus 4 multiplied by 3 exponent 3 exponent x plus 3 is equal to 0. So with this, we know our question is being given as 3 exponent 2x minus 4 multiplied by 3 exponent x plus 3, which is equal to 0. So the first thing is for us to look into the equation and identify a common base and a common exponent. Now, when we talk of something is common, it means you are comparing two or more things to find within that thing a similar identity. Then we can identify or say that those things are common. So it means that we cannot base on one aspect of the equation and say it's common. We have to take into consideration two or more. So you have to identify something that is common in the equation and equate that common exponent and base to a preferred variable. Then that will help us in our solution. So it means that identifying something common, we can see 3 exponent x here and 3 exponent 2x, which means that we can express 3 exponent 2x as 3 exponent x, and then that will be common. Then we represent this 3 exponent x by a preferred variable. So in most cases, we use y as our preferred variable. So in this video, that's what we'll be using. So it means that we can express 3 exponent 2x as 3 exponent x all exponent 2. and it's basically the same thing. So minus 4 3 exponent x plus 3, which is equal to 0. So at this point, we can see 3 exponent x here, 3 exponent x here. So what we are going to do is that we are going to let y be equal to 3 exponent x, which means that wherever we see 3 exponent x, we are going to put y there. So with the first one, then we are going to have y all exponent 2 minus 4 multiplied by y plus 3, which is equal to 0. So at this point, we are going to get y squared minus 4y plus 3, which is equal to 0. So having done this, then this becomes a quadratic equation. So we can simplify it by multiplying the coefficient of y squared by the constant term 3, and then that becomes 3. So we are going to have factors of 3. That's when we add, we are going to get minus 4, and when we multiply, we are going to get positive 3. And those factors are minus 1 and minus 3. So we have minus 1 and minus 3. So the simplified answer for this equation is y minus 1 and then y minus 3, which is equal to 0. So in finding the value of y, then we can see when y minus 1 is equal to 0, then we have y to be equal to 1. And when we come here to, we know that when y minus 3 is equal to 0, we know y to be equal to 3. And that becomes the value of y. But remember, we are not interested in finding the value of y, but rather x. Y is helping us to find the value of x. So if that happens, then we have to refer that we said we should let y be equal to 3 exponent x. So for y, which is equal to 1, that's the root of the quadratic equation. In find the value of x, then means we can put 1 here. So that is 1 is equal to 3 exponent x. Now in indices, we said that if the base are the same, then we create the exponents. So which means that 3 exponent 0 is the same as 1. We have 3 exponent x here. So right now that the base are the same, we can see s is equal to 0. Now for that of y to be equal to 3, it means we are going to put the value of y, that is 3 here. So it means 3 is equal to 3 exponent x. So we know 3 has an exponent of 1, and we compare to 3 exponent x. So right down that the base are the same, we can say s is equal to 1. So that becomes the value of x. So therefore, we can say that x is equal to 0 or s is equal to 1. So this becomes the values of x. We are not interested in finding the value of y. So that's very simple. Now let's try the next one to gain deeper understanding as well. So in the next equation, it says that solve the equation 4 exponent x plus 2 is equal to 3 exponent 2 is equal to 3 multiplied by 2 exponent x. So with this one, we first have to write our solution, and we have our question as 4 exponent x plus 2, which is equal to 3 multiplied by 2 exponent x. Now in this instance, we are looking for a common base and exponent, and we equate to y. That is our preferred variable. So which means that we can express 4 as 2 exponent 2, and we have exponent x plus 2, which is equal to 3 multiplied by 2 exponent x. So in the same way, for us to represent 2 exponent x by a preferred variable, then you have to simplify this one. So which means that we're going to have 2 exponent x all exponent 2 plus 2, which is equal to 3 multiplied by 2 exponent x. So right now we have a base and exponent in common, so we can see let y be equal to 2 exponent x. So it means that we're going to have y squared minus 2, which is equal to 3 multiplied by y. So in simplified version, then we have y squared minus 3y minus 2, which is equal to 0. So this is a quadratic equation. But remember, at this point, 2 was positive, so it means this place should be positive, then should be positive and positive. So it becomes y squared minus 3y plus 2, which is equal to 0. And that's the original answer. So if that happens, then this is a quadratic equation, and you will have to find the root of the quadratic equation by considering the factors of 2. That when we add, we are going to get minus 3, and when we multiply, we are going to get 2. So, and those factors are minus 1 and minus 2. So simply put, our simplified version for the quadratic equation is now y minus 1, and we have y minus 2, which is equal to 0. So we can see when y minus 1 is equal to 0, then we have y to be equal to 1. In the same way, when we come here, when y minus 2 is equal to 0, then we have y to be equal to 2. And this becomes the value of y. But the most important thing is that we are looking for the value of x. But remember, we said we should let y be equal to 2 exponent x. So now that y is equal to 1, then for y is equal to 1, then it means we're going to put 1 here, and we have 1 to be equal to 2 exponent x. But we said a number of an exponent of 0 is equal to 1. So right now the base are the same, then we can say s is equal to 0. Now you can see that for y is equal to 2, then we have 2 to be equal to 2 exponent x. So you know 2 is the same as 2 exponent 1, which is equal to 2 exponent x. So now that the base are the same, you can equate the exponent, and you have s to be equal to 1. So therefore, we can say that x is equal to 0 or s is equal to 1. So this becomes our solution to our question. Now let's look at something here. You see, with the root of the quadratic equation, we are getting positive. We are getting positive. We are getting positive and positive. Now, what if the root of the quadratic equation is negative? How then do we find the value of x? So our next example is going to explain to us cases where the root of the quadratic equation is positive. Is going to help us to get the value of x. So let's get the next example solved. So in our next example, we have, so it says in example 3 that given that 9 exponent x plus 3 exponent x plus 1 minus 18 is equal to 0, find x. So we can write our solution as 9 exponent x plus 3 exponent x plus 1 minus 18, which is equal to 0. So with this, then we have to look for a common base and a common exponent and equate this common base and common exponent to a preferred variable, and in this case we are using y. You can use a, m, w, it depends on you. So it means that we can write 9 as 3 exponent 2. We have all exponent x plus. Now at this point, what do we see? You see the exponents are adding and has one base, which means that originally it is 3 exponent x times 3 exponent 1. So if the bases are the same, then write one of the bases and we add the exponent, and that is what we have here. So we have minus 18 followed, which is equal to 0. So at this point, you can rewrite 3 exponent 2 all exponent x as 3 exponent x all exponent 2 plus, now we have 3 exponent x times 3 exponent 1 is 3 minus 18, which is equal to 0. So at this point, we can say that we should let 3 exponent x be equal to y. So it means wherever I see 3 exponent x, we're going to put y there. So we have y all squared plus y times 3 minus 18 is equal to 0. So we can simplify it by writing y squared plus 3y minus 18, which is equal to 0. So we have a quadratic equation here. So we have to multiply the coefficient of y squared by the constant term minus 18. So factors of minus 18, that when we add we are going to get 3, and when we multiply we are going to get minus 18, and these are minus 3 and minus positive 6. Good. So if that happens, then we can write our root as minus 3 and plus 6, which is equal to 0. So we can say that when y minus 3 is equal to 0, then we have y to be equal to 3. That's a positive root. And when y plus 6 is equal to 0, then we have y to be equal to negative 6. Now, one of the roots of the quadratic equation is negative. So how are we going to get the value of x? So with that, then remember we said that, but we should let 3 exponent x be equal to y. So for y is equal to 3, then means 3 exponent x is equal to 3. And also we know that 3 has an exponent of 1, so it means s is equal to 1. Now when we come here for y is equal to minus 6, how then do you find the value of x? So it means that minus 6 is equal to 3 exponent x. Now this is how the equation comes in. When one of the roots of the quadratic equation is negative, or both of the root of the quadratic equation is negative, we say that there is no solution, because we believe that for all values of x, 3 exponent x should be greater than 0. So values that are greater than 0, we are talking about positive numbers and not negative numbers. So for us to find the values of x, the root of the quadratic equation must be positive and not negative, which means that for all values of 3 exponent x, that is the common base and common exponent, it should be greater than 0. So based on this condition, we can say that there is only one solution to x. So that means that therefore s is equal to 1, and that is it. Now that is when one of the roots of the quadratic equation is negative, or two of them is what? Negative. Now let's go to cases where we cannot simplify the root of the quadratic equation as a base and also a common exponent, so that we can find the values of x. Now when we look at this answer, we can see that it has a common base, and then we said we can equate the exponent. Now what if it does not have a common base? How then do you find the value of x? So our next example is going to explain to us cases where we have situations like that. So let's get started and let's stay tuned for this. So we continue, and we have, it says in example 4 that if 3 exponent 2x minus 3 exponent x plus 2 plus 8 is equal to 0, determine the value of x. So with this, we first have to write our solution, and we have 3 exponent 2x minus 3 exponent x plus 2 plus 8 is equal to 0. So with this, then we have to look for a common base and a common exponent to equate it to a preferred variable, and that's going to help us to find the value of x. So if that happens, we can rewrite this one as 3 exponent x all exponent 2 minus, so this is to tell us that the base are originally what? Multiplying. So which means we're going to have 3 exponent x times 3 exponent 2 plus 8, which is equal to 0. Now remember, we can put this one in brackets in case we think the negative is going to confuse us. So at this moment, we can say that we should let our preferred variable y to be equal to 3 exponent x. So which means we are going to put y here, and we bring our exponent 2 minus y times 3 squared is 9, and then we have plus 8 here, which is equal to 0. So we continue, and we have y squared minus y 9y plus 8, which is equal to 0. So at this point, this is a quadratic equation, and the possible factors of it, that when we add we are going to get minus 9, and when we multiply we are going to get positive 8, minus 1 and minus 8. So it means we can rewrite a simplified version for the quadratic equation as y minus 1 and then multiplied by y minus 8, which is equal to 0. So it means when y minus 1 is equal to 0, then y is equal to 1. So in the same way, we can say that when y minus 8 is equal to 0, that means y is equal to positive 8. So that's the value of y. But remember, we are not interested in finding y. We are interested in finding x. But we said that we should let y be equal to 3 exponent x. So it means for y is equal to 1, then we are going to get 1 to be equal to 3 exponent x. Now we are saying that 1 can be written as 3 exponent 0 and 3 exponent x is equal to. So at this moment we have, since the bases are the same, we can say that s should be equal to 0. Now let's see the other side of the quadratic equation. So one of the roots is saying that for y is equal to 8, then means that 8 is equal to 3 exponent x. Now there is no way we can write this 8 for it to have a base of 3 and an exponent of 2. So, or for it to have a base of 3 and then an exponent. So the only thing we can do here is to take logarithm of both sides. That is, the logarithm should be a base of 10, that's a common base, and the standard base. So it means that we can have logarithm of 8 to the base 10, which is equal to logarithm of 3 exponent x to the base of 10. Now in logarithm, we are saying that if you have something like this, then the exponent must come to the left hand side of the logarithm at the same left hand side of the equation, which means that we're going to have logarithm of 8 to the base of 10, which is equal to x. So which means the x is coming to the right hand side of the logarithm. Then we have our logarithm of 3 to the base of 10. So if that happens and find the value of x, then we can write logarithm of 8 to the base 10, which is equal to x logarithm of 3 to the base 10. And at this point, we divide both sides by the coefficient of x, that is logarithm of 3 to the base 10, and we have logarithm of 3 to the base 10, and we can see that this logarithm will cancel that logarithm, and what is left is x. So we have x to be equal to, now logarithm of 8 to the base 10 divided by logarithm of 3 to the base 10, we are going to have to 4 decimal place our answer as 1.8928. So that is to 4 decimal place. This becomes the value of x. So which means that therefore our values of x is now s is equal to 0, or we can say s is equal to 1.8928. So that is how we can find the value of x if the root of the quadratic equation cannot be expressed as a perfect cube or a perfect square. So that's how it works. Now let's take an example on a situation where we are going to get the root of the quadratic equation not being able to express as a perfect square or perfect cube. So we are going to take an example on this instance too as well. So our last example for today's video. So in example 5, you are saying that find correct to 4 decimal place the value of x for which 3 exponent 2x minus 5 multiplied by 3 exponent x plus 6, which is equal to 0. I think the 0 did not come, which is equal to 0. So in this instance, we first have to write our equation as 3 exponent 2x minus 5 multiplied by 3 exponent x plus 6, which is equal to 0. So with this, then we know want to write a common base and a common exponent, which means 3 exponent x all exponent 2 minus 5 multiplied by 3 exponent x plus 6, which is equal to 0. So with this, we can say that let y be equal to 3 exponent x, which means we're going to have y squared minus 5y plus 6, which is equal to 0. So when we find the factorized version of the quadratic equation, we are going to get our root as y minus 2, and we have here as y minus 3, which is equal to 0. So now we can say that when y minus 2 is equal to 0, then we have y to be equal to 2. In the same way, when y minus 3 is equal to 0, then we have y to be equal to 3. So remember that we said we should let y be equal to 3 exponent x. So if that happens, then means for y is equal to 2, then our value of x now becomes 2, which is equal to 3 exponent x. So in this instance, remember, we cannot express 2 for it to have a base of 3 and then an exponent, so that we can say that since the bases are the same, we equate the exponent. So with this instance, you have to take logarithm of both sides. Now this logarithm should have a base of 10, and we have here logarithm of 3 exponent x to the base of 10. So if that happens, then the x is going to come this side of the logarithm. So that is logarithm of 2 to the base 10, which is equal to x log 3 to the base of 10. So what do? We divide here by log 3 base 10, and we have here as log 3 base 10, which means this is going to cancel that. So if that happens, then we can see x is equal to now log 2 base 10 divided by log 3 base 10 to 4 decimal place. You have 0.6309. So that's the value of x. Now let's try and find the value of x with respect to the other roots of the equation. So that is for y is equal to 3, then we can say that 3 is equal to 3 exponent x. Now we can see that 3 has an exponent of 1, which means since the bases are the same, s is equal to 1. So therefore we can say that x is equal to 0.6309, or s is equal to 1. So this ends today's video, and this ends the solution to our question. And so thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. Back Thinking Beyond Infinity.